Hi everyone, my name is Parag Pal and welcome back in the new video. In this video, I'm going to explain you how you can calculate moment of resistance for over reinforced section. In the last video, I explained you how you can calculate moment of resistance for the under reinforced section. Okay, so this video will help you to understand how you can calculate moment of resistance for over, okay, over reinforced, okay, reinforced section. And that is gonna be a very crucial video for all of you, because this kind of numerical comes in examinations, okay, for at least 10 marks, right? So let's get started. So you have the M20 grade of concrete, Fe4 and 5 steel. Okay, you have three numbers of the bars which is mentioned here, right? And their dimension is 25 diameter. You have M20 grade of N25 grade of concrete, means sigma CBC as a 8.5 and sigma ST as a 230, because you have Fe4 and 5. So obviously model ratio is equals to 11 if you are using M25 grade of concrete. The width of the beam is 400 mm and the depth, effective depth is 550, and you have a clear cover of 50, I would say, right? 50 mm. Now, so step number one is very simple in this situation, because here I am directly jumping on some aspect, okay, to understand how you can easily solve this. So first of all, when you are working on any of the aspect, right? So here we are gonna first of all gonna identify, okay, the step number one, critical depth of neutral axis, because to define the over or under reinforced, we need critical and the actual depth of neutral axis, right? So critical depth of neutral axis, okay, how we are calculating? So formula is xm divided by d, okay, equals to m into sigma cbc divided by sigma st plus m into sigma cbc. This is the formula. Now we want to calculate the xm, so we need to put all the formulas, all the data. So m is equals to 11, sigma cbc is 8.5 divided by sigma st is 230 plus m is how much? 11, okay, into sigma cbc is 8.5. Now you might ask me, sir, how you are going to deal with d? Okay, so in this case of functionality, okay, just remember, like, we are going to multiply this d, okay, with this factor, like this we are going to multiply here. So multiply by the depth, which is approximately 550, okay. So you will get the xm is equals to how much? 158.96 mm. So this is, you have the critical depth of neutral axis, okay. So now you have the critical depth of neutral axis with you, okay, right? Now let's understand how to calculate the actual depth of neutral axis, right? So it is a second step. So let me just use the another color. So to calculate the actual depth of neutral axis, okay, what we have to do? The formula is bx square by 2 is equals to m into ast, which is area of steel, okay, into d minus of x. In the last video I calculate ast as the first, so I can just show you that one also. I calculate in last video area of steel like this, 3 into, like 3 number multiplied pi by 4 into diameter of square, right? But here I directly start with the critical depth of neutral axis, so because I can easily calculate here also, correct? So formula is very simple, just put b value, okay, is this a 400, okay, into x square divided by 2, m value we have, which is 11, multiply by, now ast you need to calculate, so 3 number of bars multiply by pi by 4 into the diameter of bar is 25. See, this is 25 mm dia, okay. So just put 25 square into, what is the value of d? It is a 550 minus of x, right? So now if you solve this, okay, so what will happen? This is become 200 x square, right, plus, okay, if you just move all these figures in one side, okay, right, plus 1, or else I'll just prefer to answer this very quickly. If you just write down every single thing in your calculator, you will get the x value, okay, as 174.41 mm. Now you have actual depth of neutral axis, this one, and in blue you have a critical. Which is the higher? So we need to understand now relationship, okay. So just understand the relationship over here, okay, relationship between neutral axis, right? So x and xm, so x is 174.41 mm and it is 158.96 mm. So in this case, this is a situation where critical, okay, this is a critical, sorry, not critical, my bad, this is a actual, okay. So actual neutral axis is more than critical neutral axis, okay. So this section we usually called as, this scenario we called as over reinforced section, okay, okay, right. So this is over reinforced section, and for the over reinforced section we have the x is greater than xm, means FCBC is equals to sigma CBC, okay. It means FST is less than sigma ST, right. So in this situation, what is going to happen is your moment of resistance, the MR, okay, compression is equals to 1 by 2 B into sigma CBC into, okay, right, sigma CBC, right, into not into, sorry, x in bracket d minus x by 3, okay. This is also x, I'm sorry, I just made x, right. So now 1 by 2 into b is how much, 400, right. Sigma CBC is how much, 8.5 into x value is how much. Now this is the critical one, we calculate 174.41, we'll take the higher one, multiply by 500 minus, sorry, 550, okay, it's 550 minus x, okay, which is 174.41 divided by 3. So your MR, okay, which is MR in compression, will calculate to, okay, 145.83 kilonewton into meter. Very straightforward calculation, okay. So this is one of the easiest calculation that we have understood.